Hello, everyone. Today, we will learn about the design of independent control for LED lights with buttons. We will cover hardware design and program design for various requirements. First, let's look at the hardware design. Touch button. It is equivalent to an electronic switch. When pressed, the switch is closed. When released, the switch is open. The principle is that the metal spring inside the touch button moves to connect or disconnect the circuit. The schematic diagram is as shown. Next, let's review the basic principles of keyboards and debounce methods, as illustrated in the diagram. Debouncing can be achieved through hardware debouncing and software debouncing. In this lesson, we will focus on software debouncing. Now, let's explore the program design for different functional requirements. 1. Independent button control for LED flashing. Pressing a button turns the LED on, releasing the button turns it off. Single or multiple buttons can control the LED. Program design. Analyze the schematic diagram to determine which button controls the LED. For a single button K1, the program for controlling the LED on and off is as follows. Application of logical AND. The LED will light up only when multiple keys are pressed simultaneously. Symbol for logical AND, for example, if K1 and K2 are pressed simultaneously, the LED lights up. Application of logical OR. The LED will light up if any one of multiple keys is pressed. Symbol for logical OR. For example, if any one of K1, K2, K3, or K4 is pressed, the LED lights up. 2. Independent button control for LED state. Functional requirement. Bitwise NOT. Press the LED once to light it up, and press it again to turn it off. Hardware analysis. For mechanical switches, when the contacts open or close, the elasticity of the contacts causes the switch not to settle into a stable state immediately upon closing or opening. Consequently, during the moment of switching, there is a series of rapid on-off transitions known as bouncing. Program design. Analyze the schematic diagram, select the button, consider debouncing, and detect when the button is released. For instance, for a single button K1, the program is as follows. 3. Independent button control for binary LED display. Functional requirement. Control the LED to display binary values from 0000, 0000 to 1111, 1111. Each button press increments the value by 1 bit. Program design. Building on the basis of Section 2, Independent button control for binary LED display, optimize the program by retaining the delay code of button debounce and adding an unsigned character definition for LED number. Since each button press should increment the value by 1 bit, incorporate the use of the arithmetic operator, plus. Note: if functions defined later are to be called, they must be declared before the main function, such as the delay function in the program. 4. Independent button control for LED shifting. Functional requirement 1. When the independent button is pressed once, the LED lights up and moves one position. Program design. Iterating on the basis of Section 3, Independent button control for binary LED display, retain the delay code of button debounce and add an unsigned character definition for LED number. Since each button press should move the LED light one position, incorporate the use of bitwise operators. The symbol of bitwise left shift. Functional requirement 2. Control shifting with multiple keys, for example, pressing key 1 shifts left, and pressing key 2 shifts right. Program design. Arithmetic operations, plus and must account for overflow issues at the highest and lowest bit positions. The Intel MCS 51 used here has an 8-bit P2 port, so the highest bit cannot exceed 7 and the lowest bit cannot be less than 0. 3. Key points. 1. Use of if statements. Execute statement block 1 if the logical expression is true. Otherwise, execute statement block 2. 2. Common operators. As shown in the diagram, the table lists the commonly used operators. Use them according to your needs and avoid confusion. In this lesson, we covered the principles of hardware design, methods for software debouncing, and program design for various functionalities, including LED flashing, state toggling, binary display, and shifting control. We also delved into the use of if statements and common operators, enhancing understanding of microcontroller programming and hardware interface control. Finally, I will assign a few exercises to reinforce today's topics and deepen your understanding. Please complete them diligently. That concludes this lesson. See you next time.